Hello everyone. In today's video, I'm going to talk about sequential games. And what I mean by sequential games, it's basically any hypothetical game where you have a leader and a follower. The leader is going to make the first move, and the follower is going to react to whatever the leader does. Okay? And the model I'm going to use, it's called the Stackelberg model because um, that uh, that was invented by some economist. I don't really know the backstory that much, but that's the model. It's where you have one first mover, one initial mover, and then the other player reacts. So in this game I just made up, there's two players, and there's a homogeneous product. So they both produce a number of kills. So in these players are measured by how productive they are or how good they are at killing bad guys. And the leader is going to set the price, okay? And this could be anything. The price could be maybe for every bad guy they kill, they get some points or tokens or dollars or crypto or whatever. And this is basically what each player charges. Now, in this hypothetical game, this is basically a battle arena, and the goal of the game is to maximize the number of bad guys killed. So, more output equals more profit. And a coin is flipped to decide who gets to be the leader and who gets to be the follower. In my notation here, P1 is going to represent player 1, and P2 is going to represent player 2. All right. Remember, the goal is to maximize number of bad guys killed. Now, to to describe the entire output between these two players, the total output is going to be the variable y, and I'm just going to say y1 plus y2 is going to be their total. It's going to be a function of their total output or number of bad guys killed. And also, we want to assume that both of them want to maximize the number of bad guys killed. And for the leader to make the best possible decision, it has to consider the followers' profit maximization as well. And the follower has to react to the leader. So, what would a maximization problem look like in this case? Well, firm two's maximum. So we'll say player two's uh, maximization problem will be something like this. Okay. What I'm doing here is I'm actually just plugging in the total output. So I'm saying that this is a function of total output, and of course we're going to have this portion right here would be the revenue or the points they get, and then right here is going to be the cost. But in this in for today's discussion, we're just going to assume that costs are 0. So I'm going to just say that is equal to 0. And we're really going to focus on this portion right here. All right. So that's how you would describe the maximization problem. Now, the followers profit. So player two's profit depends on the output of player one. So I'm going to say in order to describe this mathematically, you would say that player two's output is a function of. So this right here is this is the player two, and I'm saying player two's output is a function of player one's decisions. All right. So now we're gonna derive something called a reaction curve. Now, to use a general function to describe that, I'm actually going to write what's called an inverse demand curve. That is y. All right, and in this inverse demand curve, I'm going to rewrite this. So I'm going to say P is actually a function, just like I said up here. P is a function of the output. And all right, and we're still assuming that costs are 0. So that means the profit then, the profit will be, remember, we're going to just focus on this. We are not considering costs at this point. So I'm going to actually, I'm going to write the profit function in terms of this expression right here up top. All right, so the profit for player 2 is equal to, all right, and solving for this, remember we're just going to simplify the inner part here. And that's going to give us ay2 minus by1 y2 plus by2 squared. All right, so what is actually, to give you a visual of what this thing is, this is actually, it's called an isoprofit line. And this is going to be an isoprofit line for player 2. So if I were to draw this out, what I'm saying here is that we have combinations of player 2's output and player 1's output. And these level curves are actually going to look like this. And what these each point on this curve represents some combination of player 1's output and player 2's output at some level of profit or some level of bad guys killed. So we'll just say like maybe this is, I don't know, this is, profit 1, profit 2, dot dot dot, profit 3. And so remember, this is just a point. This is just a point in space. So right here we have some level of y1 and y2. And there's a tangency condition because these are shaped, these are actually concave, except it's concave with related to the vertical axis. But there's a tangency condition that says at the optimum. Actually, let me just make this right here. At the optimum, the tangent line is going to be vertical. So there's an optimal point, there's an optimal point, there's an optimal point. And if we were actually to trace out this line and draw it out, it's going to look something like this. Actually, let me draw that better. All right, and remember there could be more level curves in between here, but we're just drawing out 3 of them because it's easier to see. Now this line right here is actually called a reaction curve. Okay, and this happens to be player 2's reaction curve. All right, so the isoprofit lines can literally draw out this reaction curve. And what do I mean by reaction curve? This is actually we're just saying at every level of output, this is how player 2 is going to react to player 1's decision. So at this level right here, we'll just say at y, I don't know, why not? We're going to say that at that level, player 2's reaction is going to be at the level f f2 as a function of y1. And same with here. So this will just be another one. Here's another point. Actually, I didn't need to do that. Well, yeah. Let me choose a different color. So and I probably should specify this as y not because it's a function of that point. But okay, so algebraically, so that's what it means graphically, but let's talk about it algebraically. Okay. So algebraically, that's how you derive the isoprofit function. So now we need to derive the marginal revenue. So okay. So what we're going to do is we're going to take that same equation before. Actually, and we're going to take the partial derivative with respect to y2, and that's going to equal this. Okay, and because we're assuming zero costs, we're going to set it equal to 0. And then now we're going to solve for uh, whoops, that should be 2b y2. Now we're gonna solve for y2. So this implies all right. So um, this right here is actually the player two's reaction curve, and so that going back to the previous slide, it's this thing right here is the reaction curve, whereas this equation right here describes the isoprofit, the level curves. Okay. All right, and I'm going to stop the video right here, but then I will kind of continue because now that we talked about the player 2, who's the follower in this case, so we're going to talk in the next video what the leader is going to do, so the one who makes the first move. And the dynamic of the game is pretty much that the leader is going to decide how many how many points they're gonna earn for each kill and how many kills that player is gonna make on during its turn.